For 306, it's really important that you practice a lot. I only have a couple examples here because I think that it's just important that you just get lots of exposure in the Study Forge practice problems and the Khan Academy videos and the Patrick JMT videos that are also on the site. So I just have a couple problems that might trip you up a little bit when you do your assignments, but you really should be exposing yourself to a lot more examples using exponential and logarithmic and inverse trig functions and their derivatives. Okay, so the first example is a sneaky one because they're asking you to take the derivative of e to the power of 6 times the natural log of x. But if you remember, this is actually an exponent. Property of logarithms is something you might have learned in pre-calc, where if there's a number being multiplied to a logarithm, it's actually the exponent to the argument. So you can rewrite this as e to the power of the natural log of x to the 6th power. And now that actually just equals x to the 6th power. So here's why. This piece right here, let's look at it over here for a minute. What does this equal? Let's pretend we don't know it equals this. So e to the natural log of x to the 6th power equals what? Logs and exponential functions are inverses of each other. So you can actually rewrite this expression using a logarithmic expression. And what you do is there's three pieces here. There's the base, there's the exponent, and then this is the argument of the log. Three things. This is the base, the exponent, and then the other piece. So when you rewrite an exponential equation into log form, you just need to remember that a logarithm is technically the exponent. The answer to a logarithm is the exponent. So when you rewrite this expression as a log, it's log with this base. This is the base of the exponent, so it's also the base of the log. The answer to the logarithm is the exponent, so that's this piece right here. And then the other piece is technically the argument of the log. So you just need to put the three pieces in the right place. The base of the exponent is the base of the log. The answer to the exponent, the answer to the logarithmic equation is the exponent. And then the answer to the exponent is actually the argument. Okay, so now you can just look at this as the property of equality. I call it the common sense property because this thing right here, by the way, is the kindergarten way of writing the natural log. Log with a base of e is really the natural log. That's the same thing, identical. So now if you just look at this expression, the natural log of what is equal to the natural log of x to the 6th power? It's called the property of equality. I like to call it the common sense property because if you just look at these two things, they have to be equal. That's what this equal sign says. So that means that this has to equal from the very beginning. This piece right here is equal to x to the 6th power. So this question mark from the very beginning is x to the 6th power. Another way of looking at this is if you can just remember that the natural log and the e are inverses of each other, they cancel each other out. So really could have just done this from the very beginning, and you're just left with x to the 6th power. Long-winded, I know, but it's tricky. I want you to just make sure that you recognize when you see e's and natural logs together, many times they're going to cancel each other out. You just have to write it in the correct way first. In this case, we needed to put that 6 as the exponent before we did anything. So the final answer to this would just be 6x to the 5th power because they're just asking you to take the derivative of this, which is the power rule. Okay, so here's our next example. Find the x-coordinate where f of x equals e to the sine squared x power has a slope of 0 on the interval from 0 to 2 pi, including 0 and 2 pi on that interval. Okay, so this situation is asking us for a slope of 0, which means we need the derivative, and we need the derivative to equal 0. So we're going to find the derivative and then set it equal to 0. Notice this is a chain rule situation, big time, because e is the outer level or outer layer, and then the exponent has two layers of its own. There's the square, and then inside the square is the sine. So 3 layers. We're going to start with the e and leave the exponent untouched. The next layer is going to be the power, And we leave the inside of that untouched, which is sine, and then the very last thing, which is the innermost layer, is going to be the sine. We take the derivative of that. So we'll start with the e. The derivative of that is itself. The next thing will be the derivative of this piece, which will be 2 times whatever's inside of it to the first power. And then the very last thing is the derivative of sine. So it looks like this. There's the e, which is itself. You leave everything else untouched. The next layer is this piece, which is going to be just the power rule. And you can say that this looks like this to the first power if you want. And then the last piece is the sine. So 3 layers there. Okay, and remember the next thing we do is to find when this has a slope of 0. We're going to set this equal to 0. And now we have to solve this equation. This is kind of scary. I mean, you could graph this if you'd like and stick it on a graphing calculator and find the x-intercepts. That would work. There are probably going to be decimals though when you do that. So many times this is an algebraic situation and you can solve this algebraically. You use the zero product property on this. This is something that you use when you have things being multiplied. You've seen it in the quadratic sense more often than not and probably learned the words but never really applied it. Like if you had to solve this equation, random, this is totally random, has nothing to do with this problem here. But if I asked you to solve this, you would set each one of these equal to 0 and tell me that x equals -1 and x equals +2. The reason you do that is because of the multiplication. It's called the zero product property. If things are being multiplied, if one piece equals 0, the whole thing equals 0. So same thing applies here. If this piece equals 0, or this piece equals 0, or this piece equals 0, any one of these 3 things that are being multiplied, if either one of those equals 0, the whole thing is. So that's what you do. You set them all equal to 0. Okay, so the first piece, let's talk about the sine, or the e piece with the sine. That actually never equals 0. It's just because it's an exponential equation. It has nothing to do with the fact that it's an e or what its exponent looks like. It doesn't matter. Exponential equations never equal 0. Like, for example, let's just say that instead of e, it's a 2. I mean, e is almost 2. It's like 2.17. Oh, I'm sorry, 2.71, some change. So let's just pretend it's a 2. So what if it was 2 to the first power, or 2 to the second power, 2 to the third power? Well, that equals 2, 4, 8. Gets bigger as we go this way. What if it was 2 to the -1 power, or 2 to the -2 power, -3 power? Well, this is 1/2, 1/4, 1/8, because the negative puts the exponent in the denominator. So this actually gets smaller. So this goes to infinity, and this approaches 0. Approaches 0, but I mean, think about it. If this was 2 to the -300th power, it's a really small number, but it's not equal to 0. And what if it was 0? Well, that equals 1. What if we include the fractions? Well, that's the square root. That's not 0 either. So this will never equal 0 just because it's an exponent. It's an exponential function. They never equal 0. And that's why they don't touch the y-axis when you graph them. Okay, so that one we can just disregard. This one, though, does equal 0. So let's divide by 2. And now you have to figure out, where does the sine function equal 0? You can graph the sine function if you want, or you can use the unit circle. And remember that sine is equal to 0 at 0, at pi, and then again at 2 pi. Like we're talking 0 and 2 pi here. So we'll include those, and also pi. All right, the next one is cosine. Where does that equal 0? Well, that happens at pi over 2 and 3 pi over 2 in this interval.